Welcome back to the chapter Polynomials for Standard 9. This is part 2. So, we learned a lot of concepts in the first part. So, we stopped with the remainder theorem. So, if any polynomial f of x is divided by x minus a, then if you substitute a in f of x, you will get the remainder. So, we will do some problems related to that. Find the remainder when p of x is equal to this is divided by g of x is equal to x minus 1. So, we will write p of x is equal to 4x cube minus 12x squared plus 14x minus 3. So, now here we have to find what is the 0. So, we have to equate g of x is equal to 0 to find the 0. So, you get 2x minus 1 equal to 0. From this you will get x is equal to 1 by 2. So, we will put p of 1 by 2 is equal to, we will try to find the value. So, if it is 4 into 1 by 2 the whole cube minus 12 into 1 by 2 the whole squared plus 14 into 1 by 2 minus 3. So, this is 4 by 8 minus 12 by 4 plus 7 minus 3. So, this is equal to 1 by 2 minus 3 plus 7 minus 3. So, 7 minus 6 is 1. So, half minus 1 is equal to minus half. So, the remainder will be minus half. So, when you divide with the long division, you will be getting minus half. So, in this find the remainder when p of x is equal to x cube minus x plus 1 is divided by g of x is equal to 2 plus 3x. So, p of x is equal to x cube minus x plus 1. So, now we have to find p of minus 2 by 3. So, g of x is equal to g of x is equal to 0. So, 2 plus 3x is equal to 0. From this you will get x is equal to minus 2 by 3. So, we will put x of minus 2 by 3. So, minus 2 by 3 the whole cube minus 2 by 3 plus 1. So, 8 by 27 minus. So, this is cube. So, the negative will become, you will get a negative value plus 2 by 3 plus 1. Take the LCM 27. So, minus 8 plus 3 into 9 18 plus 27. So, 10 37 by 27. Yeah, here there is this plus 1. 7 minus 6 is plus 1. So, I made a mistake. So, 1 plus half will be 3 by 2. Now, we are going to learn what is factor theorem. So, we learned the remainder theorem. Now, it is factor theorem. It is an extension of the remainder theorem. So, in a remainder theorem, if f of x or p of x, any polynomial is divided by x minus a, then you get f of a is the remainder. Now, if that remainder is 0, then you can say x minus a is a factor. For example, you divide 25 by 4, you get 6, 24 you get remainder as 1. Now, if you divide 25 divided by 5, you get 5, you get 0 as a remainder. So, you can say 5 is a factor of 25. The same thing applies here. If p of x is a polynomial of degree greater than or equal to 1 and a is any real number, then if the remainder, we did in the remainder theorem if it is p of a is the remainder. If the remainder is 0, p of a is 0, then x minus a is a factor. Here See, the 4 is not a factor of 25. See, neither 6 or 4 are factors of 25 because you get a remainder 1. But here 25, 5 is a factor because you get 0 as a remainder. So, P of A is 0, then you can say x minus A is a factor. If x minus A is a factor of Px, then P of A is equal to 0. So, both ways it holds good. So, if we do the problems, you will be able to understand it much better. So, use factor theorem to show this polynomial is exactly divisible by x plus 3. So, the same way you have to equate g of x plus 3 equal to 0. So, equating g of x is equal to 0, you will get x plus 3 equal to 0. So, x is equal to minus 3. So, you will, if x plus 3 is a factor, it is exactly divisible means it will become a factor. See here it is exactly divisible, so 5 is a factor. So, x plus 3 is a factor of Px, then P of minus 3 has to be equal to 0. So, let us find P of minus 3. Just substitute the value of x as minus 3 in this expression. So, you get minus 3 the whole to the power of 4 plus 2 into minus 3 to the power of 3 minus 2 into minus 3 the whole squared, minus 3 the squared plus 2 into minus 3 minus 3. So, this is 81, positive 81. So, 27 minus 54, then this will become 9 plus 9. So, minus 18. So, minus 6 minus 3. So, all are minus, we will add. So, 81. So, this is equal to 0. So, you are getting, since P of minus 3 equal to 0, x plus 3 is a factor. Hope it is clear for you now. So, find k so that x squared plus 2x plus 4 is a factor of this. Also find all the zeros of the two polynomials. So, if this is a, now we have k here, we have to find the value of k first and then find the remaining zeros. So, now if this is a factor of f of x, then the remainder has to be 0. So, we will start with the long division. So, this is 2x squared. So, 2x to the power of 4 plus 4, 2 into 2, 4x cube, 2k x squared plus 2k x squared. Subtract. So, you get minus 3x cube minus, so 14 minus 2k. So, this is I will write this as plus, I will write minus 14 minus 2k the x squared plus 5x. Now, I have to multiply by minus 3x. So, minus 3x cube, then minus 6x, minus 6x squared, minus 6x squared, then minus 3kx, minus 3k x. Yes. So, it is 3 minus 3x cube minus 6x squared. So, minus 3kx. Yes. Now, we have to subtract this. This is x squared term. So, minus 14. So, it will be minus 14 minus 2k minus 6. So, this will become plus. So, this is minus 8 minus 2k x squared, then 5x minus. So, it will become plus. So, 5x plus 3k into x plus 6. So, here I will write this as x squared. So, minus 8 minus 2k x squared, then minus 8 into 2x will become so 5x, 5 plus 3k. So this is 5 plus 3k into x. So here it will become x squared is over. So minus 8 into 2, it will become minus 16x, then minus 2k, so it will become minus 4kx, then it is minus 8k plus minus 8k minus 2k squared. So this will get cancelled. So now we are left with 5 plus 3k. So here this will be 5 plus 3k or 5x plus 3k x plus 16x plus 4kx. Now here it will be plus 6 plus 8k plus 2k squared. So this is what we have got. So if this is a factor, then the remainder has to be 0. So we will get 5x 21x plus 7kx. So 21, I'll write 21 plus 7k into x plus 6 plus 8k plus 2k squared is equal to 0. The remainder is equal to 0. So then 21 plus 7k is equal to 0. From this you will get k is equal to minus 7k is equal to minus 21. So k is equal to minus 3. So k is equal to minus 3. You substitute this, you equate it to 0, then also you will get the same value, k equal to minus 3. So now we will substitute. Now g of x will be x squared plus 2x minus 3. So this we factorize, we will get the zeros. So we will split the middle terms. So it will become x plus 3 x minus 3 is equal to 0. So we will get x plus 3 plus minus of x plus 3 equal to 0. So x minus 1 into x plus 3 equal to 0, from which you will get x is equal to 1 and minus 3. You equate it to 0. So you get both are factors. So you can equate it to 0. So you get 1 and minus 3 as factors. So we have got 2 factors. Now we have to find 2 more factors, because it is x to the power of 4. So now this is also the quotient. We will substitute now the quotient q of x is equal to 2x squared minus 3x minus 8 minus k is equal to minus 3. So 2 into minus 3. So this is equal to 2x squared minus 3x. So plus 6, so minus 2 you get. So again factorizing this, factorizing q of x, you get 2x squared minus 3x minus 2. So this is equal to 4. So 1 into 4, 2x squared minus 4x plus x minus 2. So 2x into 2x into x minus 2 2 into 2 4x plus x minus 2. So this is equal to 2x. I'll take x minus 2 as a common. You remember the splitting of the middle terms which you have learned in 8th standard. So now equating it to 0 to find the roots. So x is equal to, you get x is equal to 2 and 2x plus 1 equal to 0 means x is equal to minus 1 by 2. Therefore, the factors are, so now we already got this as 1 minus 3. The factors are 1, minus 3, 2 and half. This is slightly complicated, but once you keep doing, it will become very easy. So I'll see you soon with more problems in my next video. Bye for now.